Hi everyone. Today we're going to be talking a little bit about the combined gas law, and when we look at the combined gas law, if you've been kind of following along and looking at the other gas laws, you'll probably notice that it looks pretty familiar. If, for example, if I hold temperature constant, let's just pretend that instead of highlighting it red, let's pretend like it's gone. You'll probably notice that what I have left here in green, that's Boyle's law, right? If I say, let's just say I hold a volume constant, well, what I'm left with is Gay-Lussac's law, right? So this is really all of the laws that we've talked about already, just combined together, hence the name, combined gas law. So we're just going to walk you through the first problem. I think after you see one, the rest should be pretty straightforward. So we're going to start off by looking here. Everything's in bold that we need, but what I'm going to suggest that you do is write out the variables. So we've got 450 milliliters. That's a volume, right? So it's a starting volume. So we're going to call it V1, 450 milliliters. We've got a pressure. It actually says pressure there, but we would also know by looking at the unit, kPa is a form of pressure. And then we have our temperature, T1, is 17 degrees Celsius. Now, right away, what I like to do when I'm writing these, this list of variables out, I don't like to leave it in degrees Celsius. I want to convert it right away so I don't forget. Remember, we've got to add 273. When we do that, we get 290 Kelvin, all right? So there's our conversion to Kelvin. All of our temperatures need to go to that Kelvin. And what are our new variables? Well, our new conditions would be at STP. And maybe you recognize that STP conditions would be our new temperature. Our T2 is going to be 0 degrees Celsius. Again, convert that to Kelvin, so 273 Kelvin. And then our new pressure is going to be 101.3 kPa. And if you're looking for those, you're not sure what those STP conditions are, look on that little red half sheet in the bottom left corner. You've got all the list of STP, as well as in the right hand corner, the units tells you kind of if you're not sure whether it's a pressure or a volume. And in this case, we're gonna be looking for our V2. So I'll just put a question mark or maybe an X, I don't know. So now I'm going to start plugging those into my equation, and I'm going to take my P1 would be 100 kPa, and I'm going to multiply that by my V1, which is 450 milliliters, and I'm going to divide that by my T1, which is 290. I'm going to set that equal to my P2, which is 101.3 kPa. I'm trying to find V2, so that's going to be, I'm just going to write that variable out because that's what I'm trying to solve. You could use X or whatever letter you want, and then my 273 is going to go here on the bottom. All right, so now I'm not sure how your math teachers are instructing you to calculate this. I like to cross multiply and divide, so we're just going to take these 100 times 450 times 273, and we get a big number, 12,285,000, and the unit, I'm just going to show you the units here, kPa times milliliter, and then we times it by K. And we're going to set that equal to, on the right-hand side, we're going to do the other cross multiply. So 290 times 101.3 gives me 29,377. And I'm just going to focus on that so I can write a little bit better. And the unit on that would be K times, what did we do? Times kPa. And we're multiplying that by V2, right? So I like to put the variable in there because then if we're not sure what we need to divide by, we can kind of see that we've got to divide by this 29,377 so that, remember, our whole goal here is to get things to cancel out, right? To get them to cancel out, I'll use a different color here quick. To get them to cancel out, right? we want that 299 to go away. See that? So if I divide by that same thing on the left-hand side, K times KPA, all right, take a look at my canceling. So my K's are going to cancel. My KPA will cancel. So there's my answer, milliliters. And I've canceled the 29,000 on the right, so all I have left is our V2. So we solved for V2. The calculation, I believe, gives us an answer of 418. Okay, so hopefully that's helpful in doing the problem. Hopefully you can do the rest on your own. One quick little piece of advice: when you do get down here to number 3, it says STP conditions. Remember, we're using those STP conditions 0 and 101.3, just like we did in question 1. So hopefully that's helpful, and talk to your instructor if you need a little bit more help.